Hello, everyone, and welcome to this episode where we're going to be building the Cardano database sync tool and an API for it. So here we see the architecture of the Cardano blockchain tools, and at the base of it is Cardano-node, and then the Cardano-DB-sync connects to our local node and pulls the data from the blockchain and from the internally kept ledger state and dumps it into a PostgREST database, which is then queryable. So all we need to do at that point is set up an API for this database to be queryable from a remote server. So it doesn't exist only locally. It exists only locally, but it's queryable from another location, not just the server where it exists. And the Cardano has Cardano GraphQL and Cardano Explorer API. I'm not sure the Cardano Explorer API is maintained anymore, but I know GraphQL is. And I set up GraphQL, and I don't know, I'm not really a fan of it. So I think I found a better solution, at least for myself, and I'm going to show you that one today. Maybe in the future I'll show you how to build a GraphQL one, but we're going to go with the REST API for a PostgreSQL database. And that's about it. Once we have that set up, we can basically query anything on the Cardano blockchain. So like we can query information about any block, any transaction, any stake pool, whatever. So it's basically like having your own Cardano blockchain explorer. And that's it for the intro. Now let's build the Cardano node first. So I'm going to be using a combination of CN tools and Nix, which is a package manager that IOHK really likes to use, and I think it's pretty good. It makes things really easy to build. But so for the node, I'm going to use CN tools, and then for the database sync, I'm going to use the Nix package manager, and then for the REST API, we're gonna use the PostgREST API. Normal stuff from CN tools. We'll just make a TMP directory here and put the prerequisite script in there, make it executable, and run that. So once that's done, we're gonna have all the directory structure and all the scripts downloaded, and we're gonna be almost ready to start building the Cardano node binaries. So we just need to source the bash RC once it's done, and it needs to, so there's a completely new server, so it needs to install GHC, Cabal, and all that stuff. So I'm gonna just let that finish. So GHC and Cabal installed, and now it's just downloading the scripts, I think. There you go. It's done. Okay, so we're gonna source bash RC to have the installed stuff in our path, and now we're ready to build the node. So we need to, okay, git is created. Okay, so we just need to clone here. Clone the Cardano node repository, and go into that folder and yeah, we just we just cloned, so there's no need to pull. It's already up to date, and we can do git checkout 1.24.2, which is the latest release, and that's it. We're ready to run the build all script. So yeah, the node is gonna get built, and then we're going to start the node, let it sync, and while it's syncing, we're gonna do some other compiling. Okay, node is built, so we can clear that. Go to the CNode home folder, and we don't really care about any of the. I mean, normally we would alter some stuff here, like the CNode port, maybe if you want to, or the topology, setup topology updater, all that stuff. But this is just a node that's supposed to be synced. It's not a relay, it's not anything. So we can just start it, and the default topology will be just the IOHK relays. So we'll do that, and we can still deploy it as a systemd service, and there's a script for that. We don't need topology updater, and that's it. So now it's a service, and we can start it. Start CNode, start service. Okay, check the status. It's running, and we can do the guild live view. So there we go. It's syncing, and obviously it's gonna take some time because there's like 200 epochs to go. But that's working, and in the background it's syncing. While that's doing, we can build our Cardano database sync tool. Just build the binaries. Before we actually build it, we should set up a Postgres SQL server, so that where it can actually dump the data. So let's do that next, and then we'll set up the then we'll build the Cardano-DB-sync. So for building the PostgreSQL server, I'm gonna refer to the CNTools documentation again. Now, the documentation on CNTools about DB-sync is a little bit out of date, needs to be updated, but this part is fine. So this is sort of a small script that's going to determine your OS system and distribution and install the Postgres server to accommodate for that. Now, obviously, I'm running Ubuntu, so this part is going to get executed, but you can just copy it all, and so it will install the Postgres server, and so I just copied that in, and it is going to install. And after that's done, then we want to create a user. So the default user is Postgres. But we want to create a user, like the user I have is Node. It's called Node. So I want for that user to be able to enter Postgres and have access to the databases. So we're going to do that, give it the super user, set a password, and that's it for installing the server. Now let's just wait for this to finish installing. Okay, it's done. So install enable PostgreSQL. Okay, so like we saw, now that it's installed, we have this. We can switch user to Postgres that has been created as part of this installation, and if we do PSQL, then this is not, now we're in the Postgres database. There's nothing in there, but yeah, so we want to create a user to be able to log in with the user we have. Create role. So node is my user, that's what I want, and then I want to alter it and give it a password. And the password is going to be just Postgres for now. Okay, that's it. We can quit and we can switch user back to node. And if we do PSQL here, right, so obviously the executable is there, so that's good, but the database node doesn't exist. There is no database that the node can access yet, but everything's fine. That will change once we actually insert a database through database sync, so through Cardano-DB-sync. Okay, so let's build the DB-sync tool now. What I meant is, so PSQL, if you don't give it another argument, then it's just going to try to find a database with the name of the user. So in this case, node, and that database doesn't exist. But when we logged in with Postgres user, then it logged in fine, because there is by default a database called Postgres. So now that we've given our node user the login, we can actually specify, this is the database we want to log into, and we'll use that later. Not the database, but the specifying which one we want to log in. So yeah, if we do this, then we can log in just fine. Right, let's build the DB sync. So for building it, as I said, we're going to use Nix, and the important thing is that the directory tree, that the Git repositories are in the same directory. So if we go to our Git directory, we have the Cardano node here, and then this is where Cardano-DB-sync needs to be as well. So this is where we're going to clone the Cardano-DB-sync repository, and then we'll just use this Nix build and Cardano-DB-sync, DB-sync node. So here we cloned it. Oops. And we're in the DB-sync directory. We just cloned it, so no need to pull anything. Everything's up to date. And yeah, we can start building it. But I'm gonna open a TMX window here, start building it here, in case I need to switch back and forth, not to. Oh right, we need to install Nix. One sec. Okay, we need to install Nix too. Okay. So for Nix, I got. This is the command to install it, and this is just a repo I created to save stuff, And there's actually instructions here on how to set up GraphQL and Hasura and all that stuff. But now from here we just need the install Nix thing. So this is going to install Nix, and then we can use Nix to build the DB sync tool. Okay. Okay. Let's just source this so we have the Nix executable in our path, and there we go. DB sync starting to build. Now this is gonna take some time, if I remember correctly. Not as much as Hasura, I think, but still some time. So it's just a matter of waiting. So since it's in the TMX window, I can go back and I just want to check how the node is doing. Epoch 39, okay, not bad. Okay, so we just need to wait for it to build, but that's it. Nix takes care of all the building for us. So yeah, I'll be back once it's done. Well, looks like it's finally built. So we're ready to start now, and let's just check our node. It should be synced by this time because this took many hours. So yeah, epoch 235. Okay, so the Cardano node is synced. Now we're gonna start the DB-sync node. That's gonna take the blockchain data, put it into a postgREST SQL database. So we're gonna go back to our TMX window where we built the DB-sync, and now we're ready to create a database in which all data is going to be stored. But before we do that, let's just check. So the binary that we built should be in the DB-sync node. So if we look at DB-sync node bin, we see Cardano-DB-sync. Okay, so we built the DB-sync, but there are actually two DB-syncs. One is the DB-sync that we built, and the other one is the DB-sync-extended. Now they're pretty much the same, except DB-sync-extended stores an additional table, the epoch table with the epoch data. So we're gonna run that one, and then we just so instead of building this, we just need to build the extended one. So it's not gonna it's gonna be done in a second because everything is pretty much built. Okay, and now if we do bin, we have the extended one now. Okay, so in the instructions there's the create database now, which is this line here. So we use the pgpass file, which is already set in the repository. That basically specifies the name of the database, which will be C Explorer, and we use a script that's also in the repository called postgres SQL setup, and we use the create database from that, and we get the output all good. So that's good, and we can even do there's a check functionality here. So we get did not find any relations. That's because there's nothing in the database yet, and all good. So yeah, the database is created, the node is synced, we built the binaries, so we're ready to run the DB-sync node and start migrating everything into this database we created. So to do that, we'll run pretty much this command to start the DB-sync, except it's going to be the extended one. So got a notepad here. Just gonna edit some stuff. So the pgpass file is the same. This DB-sync node bin, that's where the binary is, and so we're gonna use the extended one that we got. The config is fine, but the socket path So this is our node socket which is running, but it's not here, so it's in our cnode/socket/node0.socket. So we need to specify that. And the ledger state specifies the folder that's going to be created where the ledger state is going to be done. So yeah, the rest is fine, and we can now run this and double check config node socket. Yeah, looks good. So we run this, and what we want to see is some blocks getting inserted. So starting from epoch 0, and there you go. So it's inserting Baron blocks, so 0, 5,000, 10,000, and so on. So now the node is basically syncing, it's populating the database. If we go to C Explorer, so like I said before, PSQL is the Postgres executable, and then we specify the name of the database we want to connect to. So it's C Explorer with the PG pass file we used, but the name in there is C Explorer, so that's the database that was created. So if we go inside, now we can go inside that database. We can do DT, and we see all the tables that are in there, and we can already probably select some, like select everything from block table, and just limit it to 1 from block. Okay, and so it's not very pretty, but the data is there. Or we can select everything from epoch, for example, and we'll see like the transaction counts for the epoch, the outsum of all transaction fees, start time. So this is the epoch number 0, which started 2017. And that's it. So I'm gonna let the node sync, and so it's actually getting late. So I'm gonna continue this video tomorrow, where I'm gonna set up the REST API to be able to query this database from another location. So see you tomorrow. So yesterday we got DB sync set up, and we left it sync so we can check that out. And we see we're now on the current epoch, and the blocks are getting inserted to the database as they're coming along. So that's all good. And now we have the data, and we want to set up the REST API. So we're going to use the postgREST, which I find to be pretty good and easier to work with than GraphQL, at least for me. So we're gonna set that up. You can check out all the documentation and stuff on here, and there's tutorials on how to set it up, and really in detail stuff. But now we just want to get the binaries for running this. So we'll get the Linux one, and I'm gonna do this in another TMX window. So I'll put it in here with the Git directories, and there's the tard thing that we have to kind of unzip. So we'll do that. No, okay. So it's just the binary inside. I thought it's a folder, so we'll just make a directory for it. Go this way and move this to. Okay. So we have the binary now for running the API, but we need to do some stuff in the database before we get it up and running. So we need to specify, the anonymous user. I mean, you can go into detail about this, with authentication, API tokens, and all that stuff. But for now, we're just gonna create an anonymous user that then will grant it access to select things from tables. So yeah, let's go do that. So we're gonna go back and go into our database. So it's called CExplorer, as we saw last time. And now we have to create a role for the create role web anon. We call it web anon, and so this role will have the no login flag. Okay, that's created, and we want to grant usage on a schema. So as we saw, let's show it again. The schema is called public for all the tables that we have. So we want to grant usage on schema public to web anon that we just created. Okay, and I'm going to do also alter the default privileges for this role. So like if any new table is created or any new view, that user, the web anon will have access to that as well. So I'm gonna alter default privileges in schema public, and I'm gonna grant select on tables to web anon. Yeah, okay. Now this you can read about this in the documentation, but it's good practice to create an authenticator role that's not the like Postgres user, which is the like default main user like root. So we're going to create in between role the authenticator. So create role authenticator node inherit, and we're gonna give it a login password so that web anon can actually authenticate through this role rather than through the Postgres role. So we're gonna set the password to Postgres, and that's it. That's the authenticator role created, and now we want to grant web anon to authenticator. So grant web anon to authenticator, and that's it. So the authenticator role can switch to web anon role. And I think that's all we need for the database. Now we can go back to our Postgres setup, and we'll need to create a config file. So I'll call it api.config. config. And here we need to specify the database URI that we're going to connect to, and the schema, and the well, I think that's it. But we can also give it the anon role, so that the one we created, the web anon. So first is db URI, and that's gonna be so postgres slash and then authenticator, and then the password we give it, so postgres. And now where is the database that it should connect to? So it's localhost, and the port is 5432 for the database we created. I think that's the default from DB-sync, or the default from PostgreSQL server, but you can check with netstat open and see what it's listening to. Chances are it's 5432. That might be just the default also for like the standard for PostgreSQL databases. But that's it, and we need to specify the database name, so CX Explorer, and yeah, that looks good for the URI. And now we need to give it the database schema name, so that's going to be public, and the database anon role, which is going to be web anon role that we created. So now we're ready to run the API with the config file we created, so API config, and we run that, and we see attempting to connect, listening on port 3000, connection successful. Okay, so the API seems to be working, so we can try to send a request and see if we get some data back. So I need the API and 3000, and then we want to send a GET request. I mean, the syntax, there's all the stuff in the documentation, and we'll go through it in another video. But right now, I'll just show you like some simple examples. So we can specify the table name. So let's say, I don't know, like the block table, and we just set limit, I don't know, 20. So let's try to get 20 blocks from the block table. Okay, we get permission denied. So so it's a problem with our database setup because we altered the anon user and gave it altered the default privileges, but probably just altering the default privileges is just for the future, and we still have to grant it access to the current tables that we have. So I think it's grant select on all tables. So grant select on all tables in schema public to web anon. Okay, let's try again. And there we go. So it is pretty small print. Can zoom in, I guess. But we basically, get the block hash, everything that's in the block table we now selected. Yeah, that's the API working. So we can select stuff from by using GET requests, using HTTP. And yeah, that's it. We built DB-sync, we set up an API, and in the next videos, we'll try to make some use of the API. So thanks for watching. I hope you find it useful. I know it's not really SPO, mandatory stuff, but it's cool. So see you next time.